I'm working all of the identities on the following trig identities worksheet that you got in class today. And your quiz will be similar to this and the other worksheets that we've talked about, which I'll remind you about in just a minute. All right, we want to prove this is secant. I think I did this one in class, but I'm going to do it again. There's very simple algebra. You find everything off of your memo page, all of your identities. You need to memorize them so you recognize them. And you use your identity page along with some simple algebra concepts like getting common denominator, factoring. There's this thing called multiplying by the conjugate, which means you change the middle sign. And that may be about it. Okay, so I decided to, about the only thing I could do here is change tangent to sine over cosine. And I'm not going to mess with this side. All right, this is over 1. And so that gave me cosine x plus, multiply those, you get sine squared x over cosine x. And so now I'm trying to add these, so I need a common denominator. So to get a common denominator, I have to multiply this by cosine and this by cosine, which gives me cosine squared x plus sine squared x, and I had a common denominator of cosine. That's 1 over cosine. Cosine squared plus sine squared is 1. That's why you need to memorize them so you'll recognize it. And 1 over cosine is secant, which is what I wanted. So I got that one. Number 2. It's cosecant x minus sine x over sine x cosecant x. I believe I did this one in class too. A good strategy many times, and I also did this on your other Verify Trig Identities page, a good strategy lots of times is to change everything to sine and cosine. However, see this cosecant minus sine here? I'm going to leave this one on the top just the way it is for now. I can decide to change it later if I want to, but I can kind of see what's going to happen on the bottom here. This is sine. Cosecant I know is 1 over sine. Keep an eye out for these reciprocals because they'll cancel. And that just leaves me with cosecant x minus sine x over 1. And so I did it. Number 3. 1 over tangent b plus tangent b. All right, now many times I want to change things to sines and cosines, but here I'm going to keep an eye on what I want. I want secants and tangents. On your memo page, you have something that tells you secant squared, that tangent squared theta plus 1 is secant squared theta. That's on your memo page. So I'm used to tangents and secants having something to do with each other. So I'm not going the sine and cosine route here. I'm trying to get this, and so I'm going to leave the word tangent in there. I'm trying to add fractions, so I'm going to get a common denominator. So I'm going to multiply, I just copied it down. Now I'm going to multiply the bottom by tangent and the top by tangent to get a common denominator. So the first fraction already had the denominator. The second fraction becomes tangent times tangent, which is tangent squared over tangent. Keeping an eye on what I want. So that gives me the ability to say 1 plus tangent squared over tangent. And then I'm done. Got to know your identities. That gives me secant squared over tangent. And I'm finished as soon as I get what I was looking for. Number 4. 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta equals 2 secant theta. All right, now one good strategy is to change everything to sines and cosines. It's already done. So I'm trying to add these fractions So first thing I'm going to do is try a common denominator. My common denominator is cosine theta and 1 plus sine theta. I suggest you don't multiply out the denominator because something might cancel later. Alright, so I'm trying to get that common denominator, but let me go a little more slowly so you can clearly see my steps. So I'm going to make this 1 plus sine theta. I'm just copying it down and leaving myself some room, plus cosine theta over 1 plus sine theta. Alright, so I just copied this down. Common denominator is this. So I'm going to multiply this by 1 plus sine theta and 1 plus sine theta. I'm going to multiply this one. This one needs a cosine. Cosine theta, cosine theta. Alright, so what does that give me? FOIL on the top, 1 plus sine theta and another sine theta gives me 2 sine theta, which is pretty exciting because I see this 2 in here. So once again, that's 1 plus sine plus sine plus sine times sine is sine squared. And this is cosine squared. And it's all over this common denominator. I'm not multiplying my denominator out. I hardly ever do. Now look what I have. What's sine squared plus cosine squared? Is 1. So I'll just write that above there. Alright, so I have, this all turns into 1 right here. So I have a 1 here and a 1 here. That gives me 2 plus 2 sine theta over 1 plus sine theta cosine theta. Keep looking at what my prize, what I want is little bitty. So somehow I've got to get this down to secant. I notice the top has a 2 in common. If I factor out the 2, I get 1 plus sine. In the bottom, I left factored. And this cancels. So I have this 2 on the top, and 1 over cosine is secant. Or it's fine to say 2 over cosine is the same thing as 2 secant theta. Number 5 is secant y plus tangent y equals cosine y 1 minus sine y. Alright, looking at what I'm wanting, I think a good idea would be to go to sines and cosines. So I'm trying to help you with how I make my decisions. Sine over cosine. Oh, okay, I have a common denominator. So 1 plus sine over cosine. Alright, looking at my prize though, it's upside down and got a negative sign. There's this thing I mentioned a second ago called the conjugate, which means you change the middle sign. And sometimes that's a good skill, especially when you're looking for something like this. So the conjugate of 1 plus sine y is 1 minus sine y and 1 minus sine y. Now again, I'm not going to multiply out the denominator. That's called multiplying by the conjugate, by the way. Okay? But I am going to multiply out the top. That gives me 1. That gives me negative sine y. It gives me positive sine y minus sine squared. These cancel. And what I have left is 1 minus sine squared y over this bottom thing. Okay, so on your memo page you have sine squared plus cosine squared equals 1. Got to know everything on your memo page. So if I say 1 minus sine squared, it leaves me cosine squared. So on the top here, I have cosine squared y over cosine y times 1 minus sine y. This cancels, and I get cosine y on the top and 1 minus sine y on the bottom. Don't let that scare you. What I did was all to sines and cosines. I had 2 fractions, I added them together. And then multiplying by the conjugate made me think of this, because see, I see 1 plus sine, and I needed a 1 minus sine. Number 6. Cosine squared x minus sine squared x over 1 minus tangent squared x equals cosine squared x. There's a few different ways to do this. I think what I'm going to do, well, first of all, this is an identity actually. That equals cosine 2x. This does. Equals cosine 2x. But I don't think that's going to really help me any, so I decided not to do that. I like this cosine squared, kind of don't want to lose it. So I'm going to keep it because I want one. Cosine squared minus sine squared. And I'm going to change tangent squared to sine squared over cosine squared. All right, and now I'm going to get a common denominator on the bottom. So I'm going to change this to cosine squared over cosine squared. All right, so it's logical. Change tangent to all these words. And then I've got to subtract, so I needed a common denominator. So I'm just kind of following the flow of the problem and see where it takes me. Okay, so now this gives me cosine squared x minus sine squared x over cosine squared x. And then I'm going to do keep change flip. So I have this divided by this. So I have this on the top, and I'm going to keep change flip the bottom. Cosine squared x over cosine squared x minus sine squared x. Oh, this cancels. And I got what I wanted. So changing tangent threw me into a fraction, common denominator, and you just watch the flow of the problem. Number 7. Sine x over cosine x plus 1 plus cosine x minus 1 over sine x. Wow, this is supposed to just all equal 0. That'd be nice to know. All right, notice these two things right here are conjugates. Doesn't really matter, but I just want to point out the term. They have a different middle sign. All right, but it's all already sine and cosine, so I'm not going to change that, but I'm trying to add two fractions, so hello, common denominator. Cosine x plus 1 times sine x. So I need to multiply this by sine. And I need to multiply this one by cosine x plus 1. So I got a common denominator. All right, so this gives me cosine x plus 1 times sine x on the bottom. Right here I get sine squared x plus, this gives me cosine squared x plus cosine x minus cosine x minus 1. Now what does this equal? That equals 1. And so I have a 1 minus 1 cancels. Cosine x minus cosine x cancels. So everything's gone on the top, and I get 0 over this, but it doesn't matter. 0 over anything is 0. So the whole top went away, and I have this, which just equals 0. Number 8. Sine squared theta plus cosine squared theta, which should sound real familiar to you, plus cotangent squared theta over 1 plus tangent squared theta. This one is what I would call swimming in the Pythagorean identities, by the way. Look at your memo page. You might want to pause the video for a minute while you look at your Pythagorean identities. Sine squared plus cosine squared is 1. Oh, I'm sorry, the back here was cotangent squared. So sine squared plus cosine squared is 1. So this gives me 1 plus cotangent squared over 1 plus tangent squared. However, 1 plus cotangent squared is cosecant squared. 1 plus tangent squared is secant squared. Need those memorized. Then I'm going to do everything to sine and cosine. 1 over sine squared divided by 1 over cosine squared. Keep change flip. 1 over sine squared times cosine squared over 1. And that gives me cosine squared over sine squared, which is cotangent squared. Now, you also have this worksheet right here that I think I've done every single one of these for you, so you could, I'm going to email you blank worksheets of all of this, or I'm going to email it and probably attach it to the homework. So you could also go back and study this one. We worked every problem for your quiz along with the one that I just worked for you.